We also have to think about how we access and manage data flowing across our networks. Again, all these things are just the architectural elements, the building blocks, and the individual design components that help us to understand modern networking today. We think about carrier sense multiple access, what's known as CSMA. CSMA is going to allow us to be able to effectively monitor the traffic flow on the network to ensure we don't run into other traffic patterns that can effectively block our ability to send and receive and cause effectively a derailment, right? So our packets get knocked off the network and their packets get knocked off the network. We have what's called a collision. And when we have a collision, what happens is those packets basically self-destruct. They're gone, and we have to resend them. So the idea is we want to avoid collisions. So how do we avoid collisions? Well, we monitor the network traffic, we monitor the flow, we monitor the wire, and we look to send traffic when there's nothing there, when it's clear. And as a result of that, if everything is good, we're then able to go ahead and we're able to send. And if everything is congested, maybe we won't send. And that's what carrier sense multiple access is all about. Now we have two variations, carrier sense multiple access with collision avoidance, CSMA-CA, and carrier sense multiple access with collision detection, CSMA-CD. We need to just understand the difference between the two to understand how they work. Collision detection, we're going to listen to the wire, and we're going to wait to hear, to see, to sense whether there's a connection that is actively being used. And the way we do this is that copper wire, we're talking about Ethernet connections that use traditional copper wire. When we send across that wire, we're using little pulses of electricity, not enough to hurt you, but enough to be able to carry data. That little impulse or pulse of electricity has a certain amount of energy with it, and we can monitor the line. We can listen to the copper wire by measuring the change, the upping and downing or spiking and dropping of voltage on the wire. This effectively tells us whether a packet is being sent or multiple packets are being sent, or whether there's nothing on the wire. No energy present, no spike in voltage on the wire, nothing is being sent. See a little spike on the wire or several spikes in a row on the wire, there's energy on the wire, somebody somewhere is transmitting data. It's a very simple but very effective mechanism. So every network interface, all the network cards you use to connect and wire up to the network on an Ethernet connection that's using copper wire, when you plug the wire in, we monitor what's going across the wire. So the network card has a built-in little capability to monitor this and listen for the traffic. So collision detection lets us listen to the wire. If we don't sense anything, we take a chance, we throw our data out there, we send it, we run it down the wire. If nobody's sending at the same time we are, our data gets to where we want it to go, everybody's happy. No big deal. But if we send the data down the wire and at the far end of the wire, right at the very edge of where we can listen and understand what's happening, somebody else is there. And we're not really 100% sure that the two of us are on the same wire because we're so far apart. We're at the edge of what's called the attenuation distance or the attenuation rating of that cable. Attenuation is the ranking or rating that we use to be able to understand that the cable can only transmit data for a distance, a certain period or a certain time across that cable based on distance. It's not really a time measure, it's a distance measure. And so what I am saying we have an attenuation rating, what I'm talking about is that the traditional Ethernet copper wire cable is going to be able to transmit it approximately, or rather transmit across approximately 100 meters or 300 feet. So if we're at about 90 meters on that cable, listening to somebody on the other end, problem is the signal may be so weak, the spike in voltage from their transmission may be so small, I may not pick it up and understand it for what it is because they're at the outer edge of that attenuation distance. The attenuation rating, in other words, is that distance that we can transmit across because of friction, resistance that effectively slows down the forward motion of the data by sapping the energy from it as it goes further down the wire till it gets to the point where it almost has no energy left and it stops moving. Before that happens, of course, we have to either receive the data or we have to boost the signal and give it more power to push it on down the next range or the next area of the cable to keep it going. So we use technology to do that. We send a cable and the data with the cable through a switch, and the switch is going to effectively boost the signal back up and give it the ability to send on down another 90 or 100 meters or whatever it is. But we listen to the cable. If we're at the very edge of the attenuation area, we may not sense the send from the other machine. If we both send at the same time, we're going to have a collision somewhere in the middle. So collision detection is all about trying to prevent that from happening. If it does happen, we have to understand that the packets ran into each other, boom, they're gone. And what we have to do is have both parties step back. We talk about them standing back or stepping back, and then they're going to go ahead and they're going to resend. But they have to resend at a different time. We have to use what's known as an offset, a random time value that's going to be inserted into the conversation. So that way I don't send at the same time you do, because if we both keep resending at the same time, what's going to happen? We're going to keep having collisions, right? So instead, what we have to do is I have to say, I'm going to wait 3 milliseconds. The other machine's going to say, I'm going to wait 5 milliseconds. Let's see what happens. And since I'm waiting less time than the other one, I'm going to send before it does. Hopefully by the time I'm done, the other machine sends and everybody's happy. We figure out that offset, that time value, using an algorithm. An algorithm is a mathematical formula that's going to be randomly generating a number, a numerical value, and that number is used as the time offset. That number is only generated when we have a collision, so we don't use it all the time, but we use it when we need to. We often use the spanning tree algorithm. It's a specific algorithm may be used for this kind of stuff if you're interested in knowing what it is. So that's the collision detection concept. If we have a collision, we step back, we use an offset, we resend. If we happen to have another collision, we keep doing that until eventually one of us randomly develops an offset time that's smaller than the other one. And over time, that would obviously logically happen. And because of that, we can then resend with no trouble. So that's going to be used for Ethernet wire, copper wire connections. That's collision detection. Collision avoidance is going to be used, similar concept, but it's not used on the wire, as we say. It's used wirelessly, because on the wire, we can listen. We can detect the spike in voltage. When we're using wireless systems, there's nothing to listen to. We're getting radio signals out of the air. There's no way to tell if there's a spike in voltage because we're not connected to anything that carries data using voltage. We're receiving and sending radio signals. It's effectively a different concept. So we have to use what's known as collision avoidance because we can't listen to anything and sense whether there's a send going on the other end. So instead of listening and detecting and then stepping back, what we do with collision avoidance in wireless networks is we are very polite to everybody. We send out a request saying, anybody who's on this connection, anybody who's on this network, if you're listening, I'm asking for permission to send my data. Does anybody have a problem with that? And then we wait. So we sit quietly and twiddle our thumbs for a couple of milliseconds, and eventually we get back some responses. Yes, I'm sending. Could you please hold on till I'm finished? Okay, sit for a little longer. I'll send out another message. Is it okay for me to send now? If nobody else comes back and says, hey, I have a problem, I'm sending, then we're allowed to send. And so the idea is that we are sending out a request to see if it's okay to send, and based on the response, we will then be given the all clear. That's collision avoidance. Methodology is I'd rather avoid the collision altogether by asking for permission, taking longer, spending more time, being more cautious in effect, but as a result, having less collisions. So we use this collision avoidance concept in effect to be able to use or to monitor wireless networks and use the mechanism to control traffic sending across that wireless interface. So this is how we actually set up and manage the sending of data across both a wired and a wireless interface using either CSMA-CA or CSMA-CD.